All right, let's take a look at section 9.6, solving right triangles. So what does it mean to solve a right triangle? Well, we've already been solving right triangles. We've been figuring out the side lengths of the right triangle. So what does it mean to solve a right triangle? If we've already been doing it, well, one thing that we haven't solved for necessarily has been the angles. So when we're solving a right triangle, we're going to figure out all the missing sides and angles in a triangle. And that right there is in the definition or vocabulary term, solve a right triangle. Find all missing sides and angles in a triangle. It's that easy. Well, before we get to that, we see inverse tangent, inverse sine, inverse cosine. That is the button that you're going to be using on your calculator to help us figure out the different angles, okay, of the missing angles that we have. Obviously, one of the missing angles, or one of the angles is not going to be the 90-degree one. It's going to be those two acute angles. So let's take a look right here. We have inverse tangent. So what's inverse tangent all about? Remember, on your calculator, if you don't know, you should see this button right here. That's for inverse tangent. Sine to the negative first power is inverse sine. And then cosine to the negative first power is inverse cosine. So those right there are the buttons that you're going to be using. Remember, your calculator needs to be in degrees, okay, not in radians. So don't forget to make sure that your calculator is in that correct state. It should already be if you've been doing the questions in 9.5 correctly. So let's take a look and move further down. So in order for us to find the angle, let's say, for example, right here in our diagram, we have angle A. And if I want to figure out angle A, we need to know, well, we need to know 2 out of the 3 sides. And we can use sine, cosine, or tangent depending on what we want to find, or depending on the information they give us. Don't forget, we have Sohcahtoa, right? Sohcahtoa. So if I'm going to use tangent of angle A and find the angle, they better give us the opposite and adjacent sides. If I'm trying to find angle A by using sine, then they better give me the opposite and hypotenuse sides. And if I want to find the cosine of angle A, then I better be given the adjacent and hypotenuse. Okay, so then what you pretty much do is you take the inverse tangent to the negative first power, and that's a button. Okay, so you want to press that button, and then you're going to put in parentheses the 2 corresponding sides that go with it. And then you come out with the number. If the number is super small or super large, then most likely you don't have it in the right setting, or you didn't use the correct trig function to find that angle. It should be anywhere between 0, greater than 0, less than 90, in order for you to get a valid answer here. Okay, because remember, these are acute angles, not obtuse. So it's got to be less than 90, greater than 0. So when can we solve a right triangle? Well, that's what we take a look at right here. To solve a right triangle means to find all the unknown side lengths and measures. You can solve a right triangle when you know either of the following. You have to either know 2 side lengths, or they give you 1 side length and the measure of 1 acute angle. If they give you that information, okay, one out of the 2 scenarios, then we can solve for all the sides and all the angles of the triangle using Sohcahtoa. So let's take a look right here. Let's see, what do they exactly want us to do? All right, so the cosine of angle is 24 over 25. So what they're saying, what we're trying to figure out here is this. If they give me 24 and 25, okay, and I'm using cosine, right? So remember, I go through Sohcahtoa. And cosine is adjacent over hypotenuse. Well, if 24 is adjacent and 25 is the hypotenuse, then hopefully we realize that angle F is the angle that we're going to be finding based off of the sides here. So what I'm going to go ahead and do right here is put cosine of f, and that is equal to the adjacent, which is 24 over 25. And there you have it, number 1. Okay, determine which two acute angles has the given trigonometric ratio. And if I were to figure out the angle, well, what you would do is you would plug in inverse cosine, and then you'd put 24 over 25 into your calculator. And most likely, once again, put the 24 over 25 in parentheses, and then you would get your answer. Number 2, it says the sine of the angle is about 0.38. So, well, we have to figure out, well, which one of these, if we're talking about sine, we're either looking at angle E or angle F. Well, which one gets us 0.38? It happens to be angle E. So sine of E, and then sine is opposite over hypotenuse. So we have rad 2 over rad 14. And how do I know that's the answer? Well, how about so what you need to do is you take rad 2, divide that by rad 14, and guess what? I get about 3.779. And maybe you can see that right there, maybe not. But it is, okay? And so that's why, therefore, I know that that's what the two sides you're going to be using. So that's kind of giving us an idea of what to do. All right, so let's go ahead right here, take a look at number 3. All right, they said H is an acute angle, and we're going to use the calculator to approximate angle H. So if they give us sine of H is equal to 0.2, what you need to do in your calculator, and practice this right now, take the inverse sine button, and then put 0.2 or 0.2 in there. And for most, you're going to have to press the second button. You've got the second command, and then most likely you'll press the sine key, and that'll take you to, if you look above that button, you'll see the sine negative first power. And so when you go ahead and plug that in, right here, we round this to the nearest tenth, and I get 11.5. And if you're not getting 11.5, check your settings, make sure it is in degrees. All right, tangent of H is equal to 1. That right there, plug in inverse tangent. Okay, so in your calculator, tangent to negative first power, and then 1. And so what that'll get you right there, this will equal 45 degrees. Okay, so make sure you got that down. All right, cosine, inverse cosine button. And right here, you should get approximately 70.7. So if you're not getting these numbers, once again, check your settings. Okay? So now, let's go ahead and put it all together. We take a look at number 7. We're going to solve the right triangle. So things that we need to look for, okay? There's 3 things. We got to find angle C, angle A, and we've got to figure out the hypotenuse. Okay, those are things that we need to solve for. I already know angle B. That right there is 90 degrees, right? All right, so let's see what we can do right here. We got to figure out the hypotenuse. So once again, since you're probably not an expert at everything yet, I got Sohcahtoa, and I'm looking at whether I want to find, using angle A, let's go ahead, let's start finding angle A. Okay, so with angle A right here, we have right here opposites and adjacent. Okay, 12 would be opposite, 6 would be adjacent. So that one right there would be tangent. So let's go ahead and put tangent of A is equal to the opposite over adjacent. So what I'm trying to do right now is find the angle. Okay, so this ends up equaling 2, right? And now if I want to find the angle, what you're going to have to do is you take your inverse tangent and then punch in 2, and you'll get your answer. So we have inverse tangent of 2, and I'm getting approximately 64.434. So if we were to round this to the nearest tenth, this ends up equaling 63.4 degrees. So that is angle A. All right, for practice, let's do the same thing for angle C. And so if I look at angle C, 6 is opposite and 12 is now adjacent. So we go ahead and find the tangent of C, and that's going to be equal to 6 over 12. And so once again, for your calculator, inverse tangent, 6 over 12, or 1/2, the same thing, right? Just reduced. So we have inverse tangent, and then we got 1 over 2. And that right there is equal to 26.6 degrees. All right. Now, what you could have done is take 180 minus 90 minus 63.4, and you could have gotten yourself 26.6. Sometimes you'll get that answer, but I think it's better to use the numbers, the actual numbers. If they have actual figures there, whole numbers or given numbers for opposite or adjacent or any sides of the triangle, and you can find an angle or a side, then please use it. The reason being, it's a lot more accurate that way. If you take 180 minus 63.4, sometimes you round a number, right? And if you use a rounded, what I tried to explain before is that if you use a number that's rounded more than once, it's not going to make the next answer any more accurate. It may be off by a few tenths or even more. So if you can avoid using rounded numbers in your answer to get another answer, avoid it. You may end up costing you rounding errors and the wrong answer. All right, so last thing right here, let's figure out what's the hypotenuse. Well, I've got a right triangle. I've got 2 out of 3 sides. Let's go ahead and use the Pythagorean Theorem. 6 squared plus 12 squared is equal to AC squared. All right, so let's go ahead and put all that together. We got 36 plus 144 is equal to AC squared. And in order for me to get AC by itself, we're going to have to square root both sides. I guess before we do that, let me go ahead and change or add things up. And I've got 180 is equal to AC squared. So finally, let's go ahead and square root both sides. And AC is equal to the square root of 180, which simplifies down to 6 rad 5 if they want an exact answer, which ends up equaling 13.4 as well, if you round that to the nearest 10. All right, so we went ahead and we solved out this triangle and we found everything that we needed. All right, we counted all the missing sides and missing angles right here. Hopefully it's pretty straightforward, right? All depends on what size they give you and what information they give. Let's take a look next at number 10. Okay, so we know 2 out of the 3 angles. Hopefully we could find number or angle Y, and that one should be pretty straightforward, pretty easy, right? Since we have 2 out of 3 angles, angle Y ends up equaling, we go ahead and take 90 minus 29 because we have our complements right there, and angle Y ends up equaling, we've got ourselves 71. So 71 degrees. Oh, sorry. I don't know what. This should be 61 degrees. All right, so there we go with angle Y. So we figured out the first part. So now we have to find the missing sides. Okay, so let's start off right here. We could use any of the angles other than 90 degrees. So let's go ahead and we have, once again, I like to put Sohcahtoa. And let's see, if I were to use angle Z, 18 is opposite, and if I want to find ZX, that's adjacent. So opposite and adjacent, that would be tangent. Tangent seems to be using quite a bit today. So let's go ahead right here. We'll put tangent of 29, okay? That's equal to the opposite, which is 18. The adjacent is XZ. So instead of tangent Z, since I know what the angle is, I put tangent of 29. And then we've got XZ. We'll get XC by itself, okay? So we got to do some algebra right here. We'll multiply both sides by XZ, or X to Z times tangent 29 is equal to 18. And if you don't like how I put XZ right there, you can always go ahead and just change that to like X, and then make segment YZY, okay? And then finally, we'll go ahead and divide both sides by tangent of 29. So XZ right here is equal to 18 over tangent 29. Whoops. And I am getting 32.5. Okay, so that is the length of X to Z. So how about if I want to figure out what the hypotenuse is, right? That's the missing piece right there. So I don't recommend, once again, using the Pythagorean theorem on this one, because I don't want to use that rounded number of 32.5. So what can we do? If I figure out right here y is Z, that happens to be the hypotenuse. And if I use angle Z, which is 29, I have 18 as the opposite. So opposite hypotenuse. Opposite hypotenuse. That's the sine function. So what I'm going to go ahead and do right here is put sine of 29. That's equal to the opposite over the hypotenuse, which is YZ. Now, are there more than one way for us to solve this problem? Yes, I could have used angle 61, right? Angle Y, and I would have adjacent and hypotenuse and use cosine there. So there are more than one way for us to solve the problem. All right, so knowing that, I am choosing just one of the several. And so let's go ahead and get y to z by itself. We'll multiply both sides by yz. So yz times sine of 29 is equal to 18. And then we'll divide both sides by sine 29. So y to z is equal to 18 divided by sine of 29, and I'm getting 37.1. And that right there is the length of y to z. All right? But like I said, you could have also used angle 61, except you would be using the cosine function right there to find the hypotenuse. All right? And there you have it. Let's go ahead and take a look at the last thing right here on number 11. Got this word problem. Hey, we could use trig and word problems. Let's figure out how right here. It says a boat is pulled in by a winch on a dock that's 12 feet above the dock of the boat. So if you don't know what a winch is, it's like a crank, and its cable is attached to it, and you're able to pull stuff. So right here in the diagram, the winch, I'll go ahead and highlight it. It's up there. I highlighted it in purple. And so you'll see maybe even cars have it, typically like maybe Jeeps or like off-roading vehicles, because, hey, they might get stuck in mud or in some dicey situation. So, you know, on the winch is on the car. They've got a cable, metal, like a rope, a steel cable, and they have like a hook on the other end. And they put the hook on around a tree or something, and the winch will go ahead and start cranking and try to pull the car out of harm's way. So there you have your definition of a winch, or an example of it. And then when the winch is fully extended, it's 25 feet. So that's why right here the winch is fully extended, and that happens to be the hypotenuse right here, because it's attached to that boat at an angle. What is the angle of elevation from the boat to the winch? So what it looks like right here, the angle of elevation, I'll go ahead and put X right there. So if that's the angle that I'm trying to find, well, what do? If that's my angle, 12 is opposite, 25 is your hypotenuse. Sohcahtoa. Which one has opposite and hypotenuse? It's your sine function. So what we're going to go ahead and do is use sine. I've got sine of x, because that's the missing angle. It is opposite over hypotenuse of 25. And then we go ahead and solve things. Now, if I want to find the angle, you just can't put 12 over 25. That won't help me get my angle. Remember, we use the inverse sign right here, 12 over 25, and you plug that into your calculator. So after you go ahead and do that, I end up with 28.7 degrees. All right, and there you go. You can now use sine, cosine, tangent to find any angle and any side of a triangle, as long as they give you two side lengths, or if they give you one side length and the measure of one of the angles. All right, there you go. Sohcahtoa. Keep writing it down until you remember it and know it off the back of your head. All right, there you go. It's 9.6.